Hello, in this video we're going to solve for the income and substitution effect by using ordinary and compensated demand functions. So here we have a utility function, the consumer's budget constraint, M is income. We got the prices of good X and good Y given as well. First thing we'll get is a marginal utility of good X. If we do that, we get Y. Marginal utility of good Y is X, setting up the utility maximizing condition and making some substitutions. The marginal utility of good X is Y divided by the price of good X. Marginal utility of good Y is X, and that's divided by the price of good Y. Solving for Y leaves us with this result. To get the compensated demand, we're going to take that result from the first slide and we're going to plug it into the utility function. So where we have Y, we're going to plug in X times the price of good X divided by the price of good Y. Simplify and solve for X. This is our compensated demand for good X. I'm not going to derive the compensated demand for good Y, but if you wanted to, you could just take this equation and plug it back into X here to get the compensated demand for good Y. Okay, now let's get the ordinary demand for good X. Once again, taking that condition we saw on the first slide, but this time plugging it into the budget constraint. So where we have a Y, we'll plug in X divided by the X times the price of good X divided by the price of good Y. So making that substitution. Price of good Y, that cancels, leaving us with the ordinary demand for good X. To get the ordinary demand for good Y, we could just take this result and plug it into this equation up here to get the ordinary demand for good Y. We will need that in this exercise. So this is the ordinary demand for good Y. Again, just taking this result here, M divided by 2 times the price of good X, plugging it into here, will leave us with this result. All right, now let's assume some numbers here. Income is 100, price of good X and price of good Y are $1 each. Evaluating the ordinary demand, consumer will buy 50 units of good X. Evaluating the ordinary demand for good Y, the consumer will get 50 units of good Y. At 50 and 50, utility will be 2,500. All right, next, the price of good X increases to $4. Solve for the income and substitution effect of this price change. So looking at our ordinary demand for good X, the consumer now will only buy 12.5 units. The total effect on the price increase is that X falls by 50 minus 12.5 or 37.5 units. So some of this fall is going to be due to the substitution effect. Some of it will be due to the income effect of the price increase. So the overall effect here is that X falls by 37.5 units. We want to decompose that 35.5 units into a substitution effect and income effect. To get the substitution effect, we are going to take our compensated demand that we found, and we are going to hold utility or real income constant at 2,500 and just see the effect of a price increase. So evaluating this compensated demand at U equals 2,500, price of good Y at 1, and the price of good X now at $4, the consumer would buy 25 units. This is now allowing us to isolate the substitution effect. So the substitution effect of the price increase is going to be given by X falling from 50 to 25 or a 25 unit decrease. So the substitution effect of the price increase is that X falls from 50 to 25, which is a 25 unit decrease. The total effect of the price increase is just the substitution effect plus the income effect. So we know the total effect is 37.5, the substitution effect is 25, so we can back into the income effect as 37.5 minus 25, or 12.5 units. And that's how you isolate the substitution effect and income effect of a price change. Okay, I hope you found this video helpful.